Hello everyone, this is Bradley. So I think here's where we left off last time of making the plasma animation. So if you haven't watched that tutorial and you would like to learn about the plasma animation using animation nodes, so you can go through the link at the right upper corner or the link in the description. Either way it will work. And today's topic essentially is about to make the interaction between all these splines and outer sphere, so that the plasma animation will look more realistic. But before we go into that topic, I want to mention several changes I made to the Noda Tree. One change is I added a parameter of seed. So basically this is just an integer parameter and I multiplied that with index. Originally I'm using an index to control all these random seeds to the vector so that all these points go to different locations. And now if I'm just changing the seed, then all different splines go to different locations. It's just a kind of settings you might be looking for. The reason I use a multiply is because if I add using add, the seed change will be very minimal to all these numbers. The reason for that, if you think about the index, for a 35 instances, it will go from 0 to 34. This is how index works. But if I'm just adding 1, then the number will go from 1 to 35. So you can see there is actually a chunk of overlapping of these random seeds in which the location will actually not change that much. Only two locations will be very different. So instead of using plus, I'm just using a multiply. So that technically speaking, you might still have overlapping, but it's very minimal, especially if you change the seed number very large. Just to be cautious, you can never get the seed into 0 because everything will tend to be 0 by this equation. But just to get a large number, then it will solve all the problem. Another change is a technique taught by PPAAWEUU on Twitter and also on YouTube. So I will explain this further. So basically all this expression is used to link the animation node to all these other parameters in the panels also. So I'm going to show you how it works. So now I have a parameter called x, and I'm going to use the x to define the others parameter. For example, I'm going to hold Control, Shift, Alt, and C to control this instances number. So now I get a BPY data, and finally, after a long list of expression, I'm going to define that this value equals to x. So I can use this expression to define this number. If I use an integer input, just to be cautious with that. So I'm going to, so now this is 0 and this is also 0. If I'm going to change this number to like 45, then you can see the instance number also goes to 45. It does not update instantaneously, it needs time to calculate. So you either just go to the executive node tree or just change the number, it will be fine. So this is a way to link animation node to other values in whichever places in Blender. So it does not only affect the animation node, but it can also affect other things. And if you have watched my random color tutorial, and here is how it essentially works. So I have a color ramp, a looping color ramp from red to blue and finally back to red. And I have a modulo. The modulo is basically to define a shifting of colors within this loop. And I also have a seed. So I basically use the technique I just told you. Let's take a look. So I basically use the technique that I just told you to control this y value so that I can change the seed. If I'm satisfied with location but not the colors, I'm just going to change the seeds. And also a division which control the rate of this animation. But because it's a division, so now this is 60, the shifting of color goes like this much speed. But if I'm just going to make like 20, then the speed will be much faster. You can see it basically flashing. So this is how it works. So up to this moment, this is all the modification that I've made since last time. But here's also a thing that I would like to mention is about a bug that I realized. So now if I'm going to change the curvature, you can see all this number actually, all these vectors has been drawn to one places. And this is a bug, and I'm going to fix that with you at this moment. The reason that this happens is because I'm using a loop within the loop to generate all these variances. So in this loop, I definitely use a different index number to change the seed, but outside the loop there is no seed to change that. So for each loop, I'm outputting the same variance to each location, and that's why they're all drawn by the same vector. So to solve this problem is very easy. I'm just going to add a variance or kind of a seed outside the loop as well. So by doing that, I need a integer list, and I name that to the seed. And then I need a integer range, because I must not only generate a single number, but a list of numbers. So I'm going to use this get list length to the amount. So for these locations, I need 4 vectors. So I'm generate 4 seeds, 4 of them, so that it can correspond to the seed here as well. And then I'm going to plug this list into the seed list. But at this moment, still, if you change the curvature, they will still be drawn to the same places, because I need to connect this integer range to the index. So I put the index to this starting point, and the step just can be whatever you want. And yes, another thing I need to make is now the seed has not been connected to index, so I'm just going to use a float math multiply. And now basically the variation has been created. And just again, to prove what I just said, is if you don't connect this start, connect index to this start, then they will still be drawn to one places. But now it's basically working. 0.09. You can add more values. Yes, I think that's basically it. I think basically this is perfect. You can definitely just tweak more values for your wish. And this is so I think that's it. I realize I probably spent too much time in this bug fixation, and I think I will just postpone the real topic in the actual part 2, and this part will be the bug fixation. So I hope you enjoyed this tutorial, and I'll probably see you next time. Bye bye.